Alright, here's a really quick 8.3 video. I'm going to try to do it in less than 5 minutes. And it's on how to balance a redox reaction. Alright, so we got the steps here. We got assign oxidation numbers to all the atoms. We know how to do that. Identify which are oxidized, which are reduced. Make sure that you write them down for Leo and Gur. Use one bracketing line to connect the atoms that undergo oxidation and another to connect those that undergo reduction. So what that basically means, well, let's do this step by step. So I'm already wasting time. Here we go. Iron plus 3, oxygen minus 2, carbon plus 2, oxygen minus 2. Iron over here is 0 plus 4 minus 2. All right, so what that means, the step number 3, use a bracketing line. So we've got iron going from plus 3 to 0. And we've got carbon going from plus 2 to plus 4. Okay? Make the total increase in oxidation number equal to. All right, so let's write our half reactions. We got Leo and we've got Gur. We've been practicing this now, so we should be able to do all these steps we've done in the past videos. So Leo is going to be the carbon with a plus 2 charge, becoming carbon with a plus 4 charge. Make sure that it's balanced for mass, and then put your electrons in. Now, because it's Leo, those electrons are going to go on the product side, and there's going to be 2 electrons that are lost. The way I calculated that was I looked at this 2 and this 4, and I saw that there was a difference of 2, so it gained, I lied, it lost 2 electrons, and there's only 1 carbon that's doing the losing. So we've lost a total of 2 electrons. Now let's do the Gur. The Gur is going to be iron with a plus 3 charge, and there's 2 of them, becoming iron with the 0 charge. Now this is not balanced for mass, so we got to balance it for mass first. We're going to put a 2 here. When we get that 2 there, now we can figure out how many electrons are being gained. So when I do that, I'm looking at this 3 and this 0. It's going from positive 3 to a 0, and that means that you are gaining 3 electrons for each iron. And there's 2 irons here. So we're gaining a total of 6 electrons, plus 6 electrons. So we lost 2 electrons, and we gained 6 electrons. Okay? Make the total increase in oxidation number equal to the total decrease in oxidation number by using the appropriate coefficient. And then make sure that the equation is balanced for both atoms and charges. This is what we're working on right now. We have to balance these charges. So here's how we're going to do that. We're going to take this top oxidation half reaction, which is this one. I need a pen back. And we are going to multiply it by 3. Because when I multiply that whole equation by 3, I'm going to end up with 3 carbon plus 2s yields 3 carbon plus 4s plus 6 electrons. I just distributed this 3 here, here, and here. Okay? Now I have a new half reaction where the number of electrons that were lost is equal to the number of electrons that were gained. And we're going to look at these. That's a highlighter. It's a pretty yucky highlighter, but that's a highlighter. We're going to look at these coefficients, and we're going to stick them back into our main equation. There's a 1. There's a 2. Okay? We're going to stick them back into our main equation. So this 3 goes in front of the carbon plus 2. This is the carbon plus 2 right there, where I just, here, I'll get a pointer, right there. So right in front of it, I have to put a 3. Okay, so that 3 that's here now goes up here. In front of the Fe2 with a positive 3 charge, which is right here, there's a 1. So I'm going to put a 1 there. Then I'm going to take the carbon with a plus 4 charge, and in front of it should be a 3. So that's over here, carbon with the plus 4. I'm going to put a 3. And then finally, I have in front of the Fe with the 0 charge, I have a 2, and that's here. So I have to put a 2. So now, I'm just going to take this and shrink it down so it's out of our way. And we're going to look at this equation up here and make sure that everything is balanced. Okay, so let's move this out of the way. I'm running out of time. I told you 5 minutes. So here we go. We got iron, we got oxygen, we've got carbon, we've got iron, we've got oxygen, we've got carbon. So on the reactant side, which is over here, we've got 2 irons, we've got 3 plus 3 more oxygens, so that's 6 oxygens, and we got 3 carbons. So let's write those in. We've got 2 irons, we've got 6 oxygens, and we've got 3 carbons. On the other side, we've got 2 irons, we've got 3 carbons, and we've got 6 oxygens. So guess what? They're going to match. So 2, we've got 6 oxygens, and we've got 3 carbons. And because everything matches, we have a balanced reaction according to the redox method. Voila, 5.5 minutes.